All right, welcome, guys. So, I know this is a little different than how we do it. Obviously, you're at home, and so am I. And there's like a can of diced tomatoes in the shot. But we're gonna make the best of what we can do. These diced tomatoes are actually supporting at my phone, which I'm using to record. Fun fact. So I want you to go ahead and find a piece of paper or an empty journal or just any paper you've got, and we're going to use it to take our math notes for today. So go ahead and pause the video if you need to. Find a piece of paper and title it Scatter Plots. Title this piece of paper Scatter Plots. We talked a little bit in class about a scatter plot. We've kind of seen it reoccur over and over and over again on different homeworks and quizzes and whatnot. So now it's time to actually talk about it. We've talked a lot about the word scatter, or at least I think we've mentioned it a couple times, where like when you think of scatter, you probably think of like things running all over the place. Like you're playing tag and someone goes scatter and everyone starts to run, or when you turn on light, you see bugs scatter and they kind of go any which way. So scatter means to go all around the place, and a plot is a type of graph. So you can kind of get the idea of what a scatter plot's going to be just from the name, right? So what we're going to start with is we're going to draw a table. Draw a table, and this table needs a title. So put a line for the title, and the title is average height of boys. Average height of boys. So we're going to be looking at some data taking the average height of boys. And so we're going to have two kind of labels within here. Just going to make it look like that. And the first one is going to be age, and then obviously height, right? Because we're looking at the relationship between those two things. What's the relationship between age and height? And you might already be thinking, well, yeah, I mean, when you get older, you grow taller. You've known that since forever. And so, but we're actually going to put down the data and then graph it. So the age is going to be in years. I'm going to write that off to the side. And the height's going to be in inches. It's important to know because, I mean, if we're talking about feet, then I don't think we're talking about humans anymore, right? If we're talking about like 9 feet tall, 20 feet tall, 63 feet tall. So we need to make sure we label it somewhere that we're talking about years for age, not months, not decades, we're talking about years. And we're talking about inches for height. And now we'll just kind of toss in some data that we think we might get from this. And this might be data that you get by charting one person and like charting their growth as they get older. That might be something you already do, is tracking your height the older you get. So we're going to do when this person is 9 years old, they're 54 inches tall. When they're 10 years old, they're 56 inches tall. 11 years old, 59, 12, 61, 13, 63, and I'm going to make a skip here. I've been going in order, but I'm going to skip right here, and I'm going to go all the way to 15. When they're 15, they're 68, and when they're 18, we'll do 70. So now we have some data here, and the data in this table is telling us that this boy is obviously getting taller every year. But we can also see, look at this jump here. Like from 9 to 10, they grew how many inches? 2, right? But then from, let's see, 10 to 11, look at that. how many inches is 56 to 59? That's 3 inches. So they're not growing by the same number every single year, which, I mean, again, you already know that. You don't grow by the same number every single year. It's kind of random. You don't really get to choose that or predict how much you're going to grow year to year. And so what we're going to do is we're going to now create a coordinate grid. And it's not going to be the prettiest thing in the world because we're not using one that's already made. So if you have a ruler, I recommend busting it out right about now, or anything that just has a straight line on it, because it does get kind of tricky labeling a grid like this when we're having to free draw it. So we're going to make a coordinate grid. It's going to look like this. We're making a coordinate grid, so it has an x-axis and it still has a y-axis. But these axes are labeled. Now, it doesn't really matter which one you label which, but you tend to want to put what number you think is going in the kind of input on your x-axis. Now, when I look at this, there's not really a number that's going in, but you see how the age was kind of first? So when I think about it, I think age should go here. You could flip it, but it looks better if it kind of matches your table. So the age in years is going to go on bottom, and that means the height in inches goes on the side. And by labeling it right off the bat, before we even have done any of the data, we can make sure that we don't forget it, because we often forget to put these labels. And I've told most of you guys, without the labels, your data means squat. It means nothing. I don't know what it means if you just hand me a graph that's got a bunch of dots all over it. What does that mean? Without the labels, it won't mean anything. And the biggest label of all is the title. So the title from right here is just going to be right here. Average height of boys. So make sure we have, sorry, I lost you for a second. Make sure we have our title there. And now we're going to draw our lines. And this is where, if you have a ruler, use a ruler, because these lines don't have to be perfect, but you definitely don't want them to be like all over the place. So I'm going kind of as neatly as I can. I'm trying to do it fast, but you have more time than I do. So if you would like to pause and actually take your time making these lines, that would be totally okay. I know some of you just can't stand when you've got messy lines, and I feel you on that, but I need to go quick. So I made my x-axis lines, and now I'm going to go up the side a little easier because I kind of already have some lines I can follow, right? Like the lines of the paper. I say that, the lines still look terrible. It's almost impressive. So I'm going to follow these lines off to the side, and these are my y-axis lines. And almost done. There we go. That'll do. It's ugly, but it'll do. And that is my mantra. So let's look at our data here. We have 9 to 18. So I'm thinking, we know this has to be 0. The origin has to be 0. There's no skipping over that. So let's count how many lines we were able to make. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So I can skip by 2 and be okay from the looks of it, right? Because if there's 12 lines and I make every line 2, then I'll get up to 24, which is above my range of 18. So that's what I'm going to do. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, and 24. And now I'm going to go up the y-axis, And let's look at my data there. I'm going from 54 to 70. Now, here's a problem we haven't encountered. Yeah, I'm starting at 0 right here, but my first number's jumping all the way up to 54. Like, so what am I supposed to do? Fill all this space with numbers between 0 to 54? Nope. We have a cheat for this. We actually really do mathematically, truly have a cheat. It looks a little something like this. I don't know. It just looks like a little curly Q you do on the axis. And what it shows is that you're making a really big jump. You're going to go from 0 to something really big, like 50. It's going to be a big jump. So that's where I'm going to start out. I'm going to start off. If I do that, I think I'll have enough. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 lines. If I jump, yeah, I'll have enough. So because I'm thinking 10 lines, I do the same thing. I count by 2s. It'll take me right up to 70. Barely enough. We barely just made it. So I'm going to make this line 50. And it's okay. Like I said, we can do that because of this little cheat code here. So 50, 52, 54, 56, 58, 60, 62, 64, 66. I thought it would take me at 50, 52, 54, 56, 58, 60, 62, 64, 66, 68. Oh, I gotta add one more line. Just barely short 70. So now I was able to make my graph to where it can contain all of my data. So now it's time to plot the data from here, onto our scatter plot. So you know how this works. If you made age down here your X, that means this is your X data. If you made height the side, then that means Y is your height data. So I'm going to go over 9, up 54. I'm going to go over to 9, up to 54. Right there is my first dot. And then let's just go ahead and do the rest. And you are welcome to, at this time, pause, do it yourself, like plot all the data yourself, and then play the video. And even skip to the end to see if your graph matches my graph. Because that's kind of all we're doing right now, right? We're just taking the data from here and graphing it onto here. I'm going to go over 10, up 56, over 10, up 56. I'm going to go over 11. That's going to be halfway between 10 and 12. And go up to 59. That's going to be in between 58 and 60. Go over to 12, up to 61. Halfway between there. Over to 13. Up to 63. About right there. So far it actually looks like it's making like a really good line, which doesn't always do that, so that's kind of surprising. 15, it's going to jump to 68. Oh, we're kind of going a little bit off track now, aren't we? And then at 18, it's going to be at 70. Okay, yeah, our line went away, didn't it? At this point, like we kind of had a little bit of a line going there. It was a little funky looking line, but it was there. It was a line. It's definitely going up. It's positive because it's going up, called positive correlation or a positive trend. But right when we get about here, what do we start to see happen? What do you think right there? Why is it not good? Why is it not continuing that pattern of going straight up? So you're right. Probably you either answered out loud or in your head is humans don't work like that, right? Like we're not going to keep going up. You're not going to be like 20 years old and like 100 inches tall. Because let's think about it. 100 inches tall, 100 divided by 12, that's like over 9 feet, right? That would be horrifying. So the curve starts to or the line starts to straighten out right about here because you stop growing at a certain point. You don't continue getting taller, you stop growing. So a scatter plot's not going to be this nice and neat thing that we've seen over and over again when doing our input-output tables, where we had that perfectly straight line every single time. Remember, we're not going to see that this time. We're not going to see that because these values aren't always so nice and pretty and go the same um, distance up each time. It's not an input-output table. There is no rule. There's no rule for how much you'll grow and how tall you'll get each year. There's no rule for that. So scatter plot shows data that can be kind of random. It can be kind of random and it can kind of be all over the place. So just be prepared for that. When you look at scatter plots that you're doing on your own, don't expect this data to be so perfect and so neat every single time. It's not going to be. It's going to be all over the place a little bit. Now, sometimes you'll see something like this, which is what I'm going to call a positive trend. I can see that the data is going up each time. And that's showing me that it's positive. It's going up. It's a positive trend. Or you might see where it actually goes down like this, and that's going to be a negative trend. And then sometimes it's just totally all over the place, like do. And in that case, there's pretty much no trend is what we call it. No correlation, no trend. So just be prepared when you do the work on your own on the student workbook pages. It's not going to be perfectly nice and neat, and it's not going to work out every single time. Be prepared for it to look a little bit messy, okay? But that means especially you need to go back and look over all of your points, all of your data, and make sure that your table matches your graph, okay? Make sure your table matches your graph. And that's going to be it for me for scatter plots. So if you have any questions, go ahead and finish the workbook pages, and then I'm going to have you upload the workbook pages onto Google Classroom just as probably a picture so that I can look over your work and let you know if you made any mistakes or what to watch out for, because this one's going to be a lot about just little mistakes, making sure you don't make little mistakes. So you're going to be uploading your work to Google Classroom. I'll be looking at it there. And then also don't worry about how much you finish. You might not finish all of your work in the time that you have for the math lesson, and that's okay. You're worried about just getting at least a couple problems done. I mean, if you can finish all the work, definitely finish all the work. But if you can only get a couple problems done, that's totally fine too. Upload those couple of problems, because that's, you know what, that's better than nothing, right? And we can always finish more the next day. All right, that's it. I'm out. Again, if you have questions, send them to me, and I hope to see you guys soon. Bye.